So, hi guys. Do you hear me well? Am I too loud or... because I feel like it's too loud. Okay, so, my name is Orhan. I'm working at Global Logic, and today I want to talk to you about our experience, what is to be an architect. So it's kind of a usual approach to solution architecture that we use in our day-to-day work during solution development lifecycle. And I talk about this because I usually do around 40+ projects a year, and they are very different. It may be some projects that are starting at the initiation phase, whenever we work with customers, doing some pre-sales. It may be a project that is already ongoing one. We simply do some technical consultancy, or a finishing project where somebody wants, customer or the owner of the project, to add something more, more value to it. So kind of the whole picture, what does mean architecture? And why I wanted to talk about it today here at Devoxx to you, because there are many architect titles in the market today, like QA architect, Java architect, enterprise architect, blah, blah, blah architect. So there are many architects. So who is responsible for what? What does it mean? The truth is that the title is only one word, architect. It may be your official title, it may be official position. Everything else, those are simply roles. So one person can take one role. I can be a Java architect, or a digital architect, or a QA architect, or I can do many things. So you can take many roles. From that point of view, today we will be speaking about everything, what we call architecture, of course from personal experience and with a real-life example that I will be using for this presentation. So whenever we say architecture, first thing is the common approach. So architecture is not about code, it's about approach. And you can do the coding architecture, you can do the code level architecture, but again, it's not about writing the code, but it's about the approach. And usually the approach should be based on some problem statement, because if there's no problem, then why do we need an architect here? It's simple about write the code and you have the result, is it? Do you agree? Okay. So, what is the common approach and what is the problem that we're going to solve? So, considering simply a project from the very start to the very end, it's about the idea. Any project starts with an idea. Somebody comes here in the room and says, I want to do something, yada, yada, yada. Tell me how I should do this. I want this project, I have the money for it, so how should I do it? The lucky path is usually about simply, you've got the idea, okay, we know what we are going to do, then we're doing some research on the market, how to do it, do we really need to do it, or for example, I don't want to take a project that I don't believe in because I won't do it, I don't believe in it. So we're doing the research. When we're fine with the results, we're setting the timelines, estimates, or deadlines, sometimes how you call it doesn't matter, and then we're starting delivery. So that's it. But usually people don't do it this way. Usually people does it by what I call with path of the chosen one. What means that, I will start writing code, and in the end I will get the result. But the result is actually a surprise. Will it be a finished product? Will it be really compiling? What it will be? When you get results, more often you have kind of, it seems like to be what we really wanted, but it's not actually. There will be bugs, there will be something to change, or it will be something totally different. Why? Because there are always dependencies. And I'm not speaking about dependencies related to coding, related to technical things. A dependency can be simply investor of your project who says that this is not what I want, and we really depend to that person. So anything around us is dependency. And the first things to do for an architect is to think about dependencies. We usually say that manager will think about it. But who is an architect? First of all, an architect is a technical manager. Architect is managing, overseeing the whole technical process. He can manage people, but it's not what he does. He's managing the whole software engineering. So we're speaking about engineering. So usually when we think about dependencies, roadmap is much more complex than simply write the code and get the result. So let's go step by step and define what is the real roadmap that we should think about if we say that we are an architect and we're doing the architecture. Okay, so where to start? We always start with goals and requirements. But what is the goal? The goal is usually just to deliver the solution. Really? Is it the goal or no? How do you think? Okay, it is the target. But the goal is, first of all, start with value. Any project is designed to bring value for its owner, for a person who is throwing in money, for the customer or yourself, your pet project, your startup, anything. It should deliver value for you, for your customers, for your users, anybody who is interested in this project. If it doesn't bring value, nobody needs it, then who cares? Why we need to develop it? Okay, from that point of view, how we can define that a project has a value, or it has a value, but what is the value? Start with awareness. We should think about why we want to deliver this project, why we implement this project, what is the reason that we want to do this project, why our customer, why the product owner, project owner wants to do it. Brings some value as a startup, for example, or any kind of project to users over the world, something. If we know why this project is here, what is its aim, okay, we're aware what's happening. We say that we know what is the business value. So continuing the value proposition of the thing is also knowing the knowledge. Do we have all the knowledge to deliver this exact specific project? By saying knowledge, I don't mean that you should be a developer, QA, or anybody else. I mean that at least you should be, again, aware what knowledge we need to deliver any specific project. For example, we need to know Golang for this project. Now, by saying that I'm aware that I need Golang for this exact specific project, I mean that I know here in our city, in our country, in our market, we have enough specialists with this knowledge that we can hire so that we're able to deliver the project. If not, we're not able to do it. Can we learn it? How much time we need for it? So you understand? Knowledge as a whole, on the level of the whole project, of the whole business. And this is the first things that architects should start with, continuing by asking questions about the reasoning. Ask your customer, like, why do you want this project? Why do you want it now? What is your motivation? Because when we say about timing, are we able to deliver, for example, think about your exact project for which you are working now. Is it possible that you finalize this project in next 6 months? If you do so, are your users happy? Let's say we assume yes. Okay, now, if we say that we can finalize it in 6 years, are your users happy? Will there be any users after 6 years? There will be competitor projects. Okay, are you happy with it? Will you be happy working with your current technology stack that you are using now after 6 years? I think no, because there will be something more modern. Nobody's using like Java Enterprise 5 today, but somebody started to do a project with it. Now we're going into support projects. So this is what I'm speaking about. What is the motivation of doing this project, and what is the right timing to deliver a project? And if you see that now it's too long, then it's a matter of thinking about bringing in milestones, like 3 months for POC, 6 months for MVP, another milestone, and so on. So scoping and the scoping. And these are also topics that an architect should think about. I will be speaking about technology today. It's not going just to be like business kind of styles, but continuing the methodology. After this, we're ready to speak about requirements. And usually requirements that we receive sound like there are no requirements. Like, for example, customer says, I want a calendar, a mobile app. I want it to show me push notifications. I want it to work with my contacts book, and it should work in multiple time zones and regions. Is it a list of requirements? I don't see here requirements at all. It's just a story of what are we developing. So usually it's this way. So architects' work is also to get together with product owners, analysts, and other people, go into details of requirements, what really customer wants, then split them to functional and non-functional requirements, and usually architects are working outside of non-functional requirements. But is it true? If you don't know what functionally you have to do, how you can do it non-functionally correct? For example, do I need microservices for an application that will have 10 users and during a week? Just because it's a nice solution, I don't have to do it this way because it's kind of good, yeah. Look how pretty my code is, like this approach. We actually don't need this approach. So an architect should think about all this stuff to bring in value in the end, because if we don't bring the value, then your customer, why he or she is working with you? So this is the question. And after we have all these answers, usually what we do, we start the project, if we are starting the project actually, if it's a new one. So I call it project initiation, what means that you also are into thinking about financials. Because you say, finance is something managers would do, owners would do, they will sign contracts, sales and other people, but any solution that are using some non-open source technology, or at least cloud, there is a cost for that. And architects should know the cost. Architects should be able to calculate the cost for the whole project cycle, at least for a year, for let's say, per annum. Then, are we going to use IntelliJ IDEA, the enterprise version? It also has cost. How many developers will we have? Then now calculate what is the cost for our customer. So architects are thinking about budgets. Next thing, efficiency. If we say that we know Java or Scala or anything else or PHP, it doesn't mean that this is the right stack. What is the most efficient way to deliver this specific project based on our findings, goals, requirements, financials? What is the price in the end? How much we want to get effort for that? The time budget also, how much time we have to do it. So think about several ways. We have many ways of delivering a project, but what is the most efficient way of doing this exactly in this case, today, right here, right now, for this exact project? Next thing is knowledge. We have talked about it. What knowledge do we need to hire? Do we have everything we need in our company? Do we have these people in our city and so on? And this is the preparation step where we also have just simply add some metrics. How we will know every week, every month that we are doing as we planned. And based on that metrics, have some reports. Because if you don't have reports, many usually engineering companies fail in, I call it software engineering companies that fail in software engineering. Because usually they don't have reports. We don't know what's happening. We're developing already for 6 months and we don't know what's happening. It's not just about burn down charts, about methodology like Scrum, anything else. It's about initial preparation that we did. And are we really going this way, in this direction? After you have done this homework, all of these exercises, now we're ready to go into architecture and design, the technical part. Now we know what are we speaking about. Technical part here is, first of all, about understanding the task. If we go back to our requirements section, customer said he wants a calendar, a mobile app. What are we going to do? We're going to develop a backend, let's say in cloud. That was a requirement. We are going to have Android and iOS. Nobody told us which operating systems, but then we started negotiating processes, we started refining requirements, and we defined that they want only Android and iOS, nothing else. Great. They are pulling data from cloud, And we were speaking about push notifications. Yep. And server is pushing something to our clients. Okay. Now, it's time to design the solution. Usually, we call it solution architecture, but there is a reason why I called this slide backend architecture. And I will return to it in a few moments. But first, let me show what kind of a solution architecture can look like. If you are a technical person, you are drawing a diagram, like circles, other figures, drawing arrows between them. But an architect's job is not just be a technical person, because if you are an architect, you're a smart person that did coding, QAing, DevOps, other stuff, and you are just senior enough, you are an expert to call you an architect. But are you really an architect if you can't talk in language of business? You have to be able to convince any business person that you know what you are doing. And in context of business, usually our drawings are going to be much more simpler, like this one. For example, we have iOS and Android. Okay, first of all, we say there will be a public API, an API gateway which receives all requests. Okay, HTTP REST or anything else, doesn't matter. It will be a public API because it's open to whole internet. Then, we will have data services, and many people here argue that data services is a wrong term, and I agree. But sometimes you have to simplify terminology to be able to give more people, not only technical persons, but to top management, tell them who are going to pay you, your customer, what do you mean? So data services are services that are going to hide the database behind them, microservices. Users are working with user database. There will be many users. Just because we are speaking about high availability, it's a cloud solution, but there will be also other services. They will hide databases behind themselves by giving us API to work with them. So how we should work it? Okay, now we have domain API services like calendar API, which will reuse some of them, scheduling API, blah, blah API, and they will reuse data services. It's good. Okay, we can have event-oriented approaches, we can have non-eventual architecture. It doesn't matter at business level. It is the technical details. We should have drawings, blueprints, how we're going to do it, to speak to technical people. For business, we also have to think about there will be something called common concerns, which simply takes authentication and authorization, caching, monitoring, logging, tracing, configuring everything, and anything else. This is not business logic. So it's a separate thing. It can be Kubernetes with service mesh and other stuff, or anything in the cloud, AWS, GCP, Azure, anything. So this is what is usually called solution architecture at a high level solution architecture. But why I called it back-end architecture? Do you see here front-end? Mobile apps are not front-end. There is no front-end here. This is the most crucial part that's most of the times people simply skip it. They don't do the front-end architecture. But hey, guys, there is front-end architecture because mobile app, I will have user interface. It will be using layered architecture. There is also data access layer for accessing the public API and fetching the data or sending data there. Then there is a business logic layer. UI has a business logic, how things are going to be working simply. Presentation layer, the components we're going to use to render this thing. And then routing layer. Menu is pressed, we're showing one page. Another menu, second page. So we're going to do the things. It's a layered architecture on the front end, and it is simply user interface because the rest is, we're speaking about mobile. Environment services, there will be network, there will be camera, there will be storage. For example, with camera, you can scan something and add an attachment to a meeting in the calendar. Or add the contact using its like QR code or anything else, for example. Or scan a phone number using machine learning at the back end, define what is it and add it to contacts. Then there will be notifications usage here. Storage is about keeping things offline. When your user is offline, you have to work with local storage without internet, so you have to cache things. Notifications, you have to work locally with notifications, showing the badge number, how much notifications we have on the icon of the app, for example, on iOS. And this is architecture because we have an integration layer. This is just one app. Because you have to put in a navigation interceptor. Whenever a menu is clicked, maybe there is a need to switch on camera. Somebody should intercept it and integrate with camera, show camera, you got a photo, then how we are sending photo there to our UI. There should be a communication interface. And in mobile apps, it's usually, how it's called, event-oriented. In Android and iOS specifically. So this is the part that usually people simply miss. And this is why I am telling this. I have two slides, back-end architecture and front-end architecture. Think about both layers separately. And the last part, what is also sometimes missed, data architecture. Sometimes people simply don't talk about data. Like, we will have a database, it will be SQL or no SQL, and that's fine. Come on. There is a point where you have to think about what will be the format of data. You remember the most efficient way. Are we going to store JSONs? Are we going to have tables with IDs, primary keys, so SQL database? Are we going to have a big data cluster or a file system with a CSV, with a bunch of CSV files? For each specific case, there may be a requirement that tells you for this exact data, for this part of the system, you have to keep data in some kind of different format. And usually people know, sometimes they're missing this part. Additionally, people sometimes miss also the locality principle, what means that the local point in the system where the data fetched from the data store is going to be processed. A simple example, SQL database, which is doing a select where order by some column. It's a sorting operation. It takes some CPU time and some memory. Do you want it to do on the node where the database is located, in the database inside itself? Or you can simply fetch the data and let UI to sort it in the order whatever it likes. Do we have to use resources for that? It's a simple example, but everything starts with simple examples. And then when you have a big data cluster, sometimes people come and say, we have too much of memory usage or too much of CPU usage for some kinds of operation. Because, come on, if it's built in there, it doesn't mean that you are thinking about it and you're doing it correct. Think about it. The next thing is about the structure. I like when people come and say, hey, we're going to use here MongoDB because we have a liquid structure. Then I ask, why you have a liquid structure? Because requirements change during the development. They are adding fields. Does it mean that the data structure is liquid? Nah. And MongoDB doesn't mean that you don't have a structure, for example. The JSON is the structure. It has fields, arrays and fields, and so on. So think about the most efficient structure for storing a piece of data. And there will be many different options to pick from, and they will be different from service to service. It's good. And the last thing, I love it. Indexes. I like people when I say, show me your indexes. And they say, we have indexes everywhere for everything. If every column in your database is indexed, it doesn't mean that an index will be used at all. Most of the times, developers miss the point that when I'm developing something, I'm writing queries, bringing indexes that cover those fields that you're using in your queries for selecting the right data, or doesn't matter if it's kind of as normalized, denormalized SQL, NoSQL, anything. But it also doesn't mean that with each next deployment, You don't have to revise your indexes because you have bring in more queries and something is removed. So maybe it's time to revise the indexes we have and change things around. This is one of the points which is missed. Actually, data architecture means much more, but this list is my winner list that is aimed to be the basic one from where I have to start. You can prepare your own list, but have it. And the win point is, for example, for me, a winning point for today, for my speech, would be everybody has phones, smartphones, or maybe some notebooks. Take 3 to 4 points that was something new or interesting or valuable for you, and for example, then read about it, learn about it if it's something new, or just return back to me, let's drink a coffee or tea and discuss it in details, because 50 minutes is not enough to speak about everything in details. But this will be a winning point, because you will have your list that was interesting for you. If you don't have it, then why you are sitting here? Just to listen to me? Well, I'm not a celebrity. Use your time much more wisely. But if you are here, prepare your own list, what you have learned from this presentation. And do it in this way. So this was my example. After I have gone through all of these things, now I can talk about aerial view, what means bird's eye view. Now we say the project is about bringing in Android and iOS. We are going to have front end. It actually should be vice versa, front end on the top. But I do it this way because we have specific requirement for exact specific operating systems, and the front end should be based on that. Then we say we have public API, nice. It's working with the main services at the back end, which are not reachable from the internet, just through the API gateway. Behind them, we talk about data services. It may be a data microservice, it may be a simply database with an API for direct access. Doesn't matter what we're speaking about right now, because it's much more technical detail for this moment. And then beyond that is the data store. It may be database, or it may be a data file or a data store like S3 or anything else. So think about the data as a whole. Now, next thing an architect should think about is, okay, how we are going to develop the thing. Let's speak about technology stack. So, what areas we have? In this specific project that I'm speaking about, we had mobile, of course. Then we had web, because we decided to use hybrid approach. For UI components, we decided to have a web view that will be using web technology stack to draw things, so we cover both systems with one code base. And then we will have a backend. All the native stuff is handled in the app, but the rendering is done using web technologies. Okay, that was our approach. We decided that it is good for this exact specific project. So now I need your help. I will have here backend stack options that we were reviewing. It's not just about everything we have, but just what we have reviewed in our team for this exact project. And I would like you to help me with your hands. What do you prefer for this kind of projects? So Java JVM. Okay, who would use .NET Core? Nobody? Come on. Is it because we are on Devoxx? Node.js, would you use it? Okay, a few people we have. What about PHP? I have 2 hands. Okay, so let's think about, if you are an architect, it's always about trade-off. Why we have to use Java? Because we know it? Yes, we know it, but it doesn't mean that it's better than them. Can we do benchmarks for performance, for memory usage? Can we do it based on our requirements? So let's ask our customer, what is the user number, average user number, which you are expecting to be online? What is the average latency budget? How many milliseconds you have one request to take in order to bring you data? And now we can do benchmarks. How much money you want to spend for your cloud? Okay, memory, CPU consumption, and other stuff. Now let's take benchmarks and decide, which of these is the best option for us. So it's not about I like this or that. It's about what is the best option, based on what? We need numbers. And it's always about trade-off. Next was web. React, Angular, and others. We didn't care about them. We were simply speaking about Angular and React because this was the case. We have this in our company, both. We have many others also, but we wanted to do it because it's easier to hire someone with React or get an Angular developer on the market. And the last thing was mobile. We have reviewed React Native. Have you worked with it? Anybody knows? Okay. Then Native Script. Heard about it? Okay. You can write it down and read about it. Cordova, my old friend. Yes. And simply go native. Develop an iOS and develop Android app. Do we have Android developers? Do we have iOS developers? Okay. So the rest was about programming languages because all stacks delivered kind of various options to write. For example, we could do Objective-C for iOS or get Swift, or we can get Java or Kotlin for backend, or C# or TypeScript or PHP for the front end, various parts. So could it be simply JavaScript, anything else? So there are many options, not limited to this list. And as an architect, you have to think about all this, details per each point we are setting here to define the right value for the trade-off. So what will be the final version of technology stack you are going to propose in your proposal with your prices? And can you give us guarantee that you will do it in time? So there were many options here, pretty many. So how we do it? We usually take a few challenges and think about how many of these examples from technology stack can really solve our puzzles and challenges. So I've picked 5 challenges. It's about, first of all, they're very simple. So async flows. At the back end, speaking about notifications and other stuff, at least we will have some asynchronous event-driven architecture or maybe approach somewhere. So we have to work with some kind of message queue. Okay, so which it will be, what it will be, how we will do it. Next thing was about push notifications, how we will send push notifications. There are many ways to do it. There are push vendors. You can use WebSocket or anything else. So what is the best option here? Then, battery drain. If we're speaking about mobile apps, we have to think about how much battery will our application consume. If your application simply will eat all my battery, then I will uninstall it and won't use it. It's a value for our customer. Next, traffic volume. How much data will we consume? Because we're speaking about mobile, 3G, 4G and other stuff, 5G is coming also. So we don't have guarantee that Wi-Fi will always be on. Next, offline availability. If we're working with a calendar, then if I'm offline and I open app, I don't want it to say me that, I'm offline, I can't show you your schedule for today. Maybe I'm in a train, 7 hours going to Lviv. I want my calendar to show me what am I going to do in Lviv today. So, solutions were quite simple. The problems are not really too difficult, but the approach, how we did that. So speaking about async flows, first of all, I always suggest to think about buckets. Doesn't matter what kind of events or messaging or streaming are you going to implement, you always have simply three buckets for any kind of solution, and they fall in these 3 buckets. So any messaging solution is, first of all, can be, the lines are not drawing here. Yeah, okay. So it can be a point-to-point communication channel, a thin, a quick communication channel, just like as an HTTP kind of way doing of things, but it's not HTTP. It's simply a quick channel through a middleware, through Kafka, through Rabbit, through anything else. Second option is persistent event store. For example, RabbitMQ is not going to help you here. It's already a kind of NoSQL database. For example, Kafka. It can store events for always if you have enough space. So like, we do communication, but whenever we want to get, anytime you want to fetch an event that happened a year ago, if you have stored it, you can fetch it. Go there and read everything. For example, replay all events. It's just another bucket of, another use case of messaging. And the third one is less used. It's about entity state updates. It's about a database or an object database or an object storage that can notify you using PubSub semantics about changes in events. Redis can do it, Sybase can do it. I think Microsoft SQL also did it. I don't remember it specifically, but many databases can do it. Like, there was an update to a column called blah blah, and you get a message. You have a listener that can do something with it. So 3 buckets: quick communication channel, event store, entity updates, notifications. Okay, great. So which of these do we need? I'm not going to tell you what was the answer, but just think about that any solution falls into one of these 3 options. And based on that, you have a limited list of solutions that are going to do it. Here, for example, I was talking about RabbitMQ and Kafka. Both do this. Only Kafka does it. No Rabbit and no Kafka, they don't do it. So what we need, based on that, which components, which solutions do this thing, and then let's speak based on our other requirements, what out of them is the best for us. About push notifications, that thing was even simpler and tough at the same moment. So we could use WebSockets, but have you ever used WebSockets with high availability? There is a thing called WebSocket farm. Do you know what means WebSocket farm? Read about it. Because WebSocket is stateless. Whenever I'm connected to a WebSocket server, you cannot direct me with a load balancer to another one. My session is here on this exact server. But if we're speaking about mobile, which goes offline, online, offline, online, offline, online, and we have many users in many countries, how we're going to solve it? It's a good solution, but it may be not the easiest one in this case. Then we have server-side events, which is pretty similar. The difference is that it only pushes. This one goes back and forth. But again, stateless. We wanted to be stateless, and the solution which allowed us to implement this was simply too difficult. We want something easier. And then we reviewed push providers. There were paid ones, there are free ones. So free ones say that, what is the drawback? The drawback is actually they are always free, but your data, they will share your data with their customers, X. Who are the customers? We don't know. For marketing purposes, all sensitive data will be removed, but hey, come on. My customer don't want their data to be shared with somebody third party. This is anyway sensitive data because there are many regulations to that in different regions and so on. We were speaking about working all over the world. So if you don't want them to share your data, it should be paid. And paid solution for push providers, we don't want to waste money for that because it's too much. Now, what we picked was Firebase. Do you know Firebase? Okay. It's a product bought by Google a few years ago, and now it's Google Firebase. So what it does, it gives you same thing what this did, but it's a solution with many layers in cloud that does databases, not push, but messaging, other stuff. So everything is paid, but messaging part called Firebase Cloud Messaging is free. And Google says it will be always free because this is something what they do for Android community to support it. But now listen, if you use it, you will like it. It really works very good, it scales very good, and the reason behind it to be free is because you will buy other products. So it's their marketing. But they don't share your data. Everything is good here. And this was the solution that we picked for this exact application because Firebase allowed us to share messaging topics between all clients and our backend, make it secure and cloud native. The rest was about anything else, you know, give me your option, I will be glad to discuss it with you. So, a note on API, we talked about traffic volume. This was simply about, we wanted to use REST just because it's pretty standard. But if you're speaking about mobile, think about GraphQL. It may allow you to reduce some traffic volume. Just think about it. Maybe you don't need it at the very start, but in the end, you will come there. Anything else? Take your options, get the list of benefits and drawbacks, and make your trade-off analysis. This is what we call it in architecture, trade-off analysis. We are always working with trade-offs from project to project. The last thing was about offline storage. Again, the options were like use cookies. We're using web approach, a web view. It's not an option. Web storage, a good thing without any limitations, but it's already deprecated. Then we thought about WebSQL. It's also kind of deprecated. And you know the reason. Anybody knows what is WebSQL? Inside the browser, the web browser from JavaScript, you work with a database, and this database is simply very similar to SQLite. Just SQLite for JavaScript. The reason for deprecating the whole WebSQL standard, which was the deprecation was initiated by Mozilla, was that everybody's using SQLite as a back implementation for WebSQL, and this means like we don't have alternatives, and it's bad. And that was the reason to deprecate the whole thing. If you don't use your implementations, then it's a comfortable thing for developers, but we're not going to do it anymore. And that was very bad. They introduced IndexedDB, which works now. Everybody has their own implementation, but it's very ugly. It's simply very ugly. This is my personal, consideration, but it's really ugly. Stack Overflow, people also say that it's ugly. So it's kind of a MongoDB for web JavaScript. I don't like the API at all. And SQLite. We have mobile apps. We decided to use SQLite for local caching, and we simply introduced interface, our functions and procedures, natively in mobile apps, and then bridged them to JavaScript code. Because we are developers of the application, we can do it. So it's a hybrid app. We can do mobile partially and draw the UI in the web view. UI calls a function, function is bridged to mobile app by calling a native method, which uses SQLite for caching things. This is not the best option at all. This was just something we decided to use in this specific project, and we are happy with it. It works, and it simply works for all the requirements we had for this exact project. Everybody agreed, and including customer, everybody's happy until now. So just pick the right option for you. There is no bad or good technology. Technology is not good or bad. Technology is technology. We are people, we are judging what is bad and what is good. So it's not bad or good. It's just better or not better for this exact case. So the summary is about, if we speak about technology stack, the final solution was like, this is the list of backend we used. We used Node.js for anything eventual, and we used PHP 7.3 with opcache for microservices because they simply did some kind of business logic with API handling. And you can ask why PHP, why I'm telling about it loud, because it was faster than Node.js, faster than Java. It used much less resources by our benchmarks for this exact case. And it was somewhere around a little bit lower than .NET Core by CPU usage and speed, but it was faster than anything else, and it was too low on resource cap. So costs for cloud, for this exact cloud client, I mean, really was something like a high key point. So this was the selection. I'm a Java guy, but we used PHP for this thing, and Node.js. Then CI/CD at Jenkins, and infrastructure was without Kubernetes, other stuff. It was cloud with Docker containers. Next thing, front-end stack, Angular for web part. Kotlin with Firebase and Google Vision API for Android, and iOS Swift and Firebase Cloud Messaging. I mean, we didn't need some kind of Vision API because iOS have everything inside. And the last thing, developer tools. As I said, this is also a thing that should be considered when you calculate your costs. IntelliJ IDEA and Git for backend, IntelliJ NPM and Git for web, and mobile, Android Studio, Xcode, IntelliJ App Code, because it's much more comfortable, but you cannot use it without Xcode for iOS. You have to know this as an architect because Xcode is comfortable for working with project properties, but then code is much more comfortable to write in IntelliJ, and Git for everything. So this kind of list is always attached to contract. What are we going to use for the solution? And from that point on, we're ready to start development. So the final solution architecture was kind of backend API, which worked with iOS and Android. They pulled the data using REST and GraphQL. Firebase Cloud Messaging for pushing notifications to Android and iOS, but iOS version could not do it directly. It has to use Apple Push Notification Service, so Firebase pushes it here, and then Apple pushes it to your app. And there was one thing. Apple Push Notification Service is free up to 1.5 million notifications per month. If you are doing more, they can email you that you have to pay for that. But it's optional, Apple will decide. So you see how many information? Everything was considered in drawbacks and benefits during the trade-offs. And this is the whole scope you have to cover as an architect before we start development in our project. So the roadmap was about think about the project initiation. What are the steps to take? Do your research, collect all the information, goals, requirements, technology, stack-related questions. Do the design, draw the drawings for top managers, for developers, for anybody. It can be one drawing for everybody or 5 drawings for 5 different kinds of people. Then do the development, start it, and work in teams. We start developing and build the team in process, or build the team and then start development. These can be swapped. Then do everything in time. You have to know your timelines. You have to have metrics and reportings to make sure that everything is good. This part is done by architect, management, and other guys all together. And I always suggest everybody should know what are the reports we are giving and what are the metrics based on which we work, even each developer, each QA, anybody. Everybody, it should be transparent for everybody so that we understand what are we doing and are we doing it correctly. And then, whenever you're finished, every project should have a finish line. Your project cannot be forever. You have to fix the project. Whenever you have finished it, you can start a support contract. And customers like it because as a customer, when I pay someone, I want to know how much will I pay and when the work will be done. After that, we can agree on a support contract. It's okay. Or somebody else can support me. It doesn't matter. We will agree about it. But the project should have a fixed timeline, a fixed cost, and customer should know where is the finish line. And that's it. So, on this website, it's very ugly. I'm not a designer. You can simply get my contacts, Skype, Facebook, email. If you want to talk to me, add me, send me any of your questions, or just let's go and speak in details after this talk. Here, I usually post this is a Facebook group where I post some interesting articles that I liked, that gave me something new, understanding of something new for me. I learned from them, and I usually tell people that let's learn together. So that's it. Thank you.